Unit 5, Formative 2 Review. In this section of the unit, we talked about proportions, percent problems, and percent of change. You can use this video to brush up on all of these skills. When solving proportions, you can solve them using cross products every single time. However, there are a couple of shortcuts that you can look for to make the math a little bit easier. The first thing that you always want to look for is an easy relationship between your numerators or between your denominators. For example, on the first problem, 7 is to 12 as 28 is to x. If you look at at your numerators, you can see this nice relationship here. These are just equivalent fractions. So to get from 7 to 28, you multiply by 4. So for this equal sign to, be real and be legit, you would have to do the same thing on the bottom. So the easiest way to get your answer on that one would be 12 times 4. When you do 12 times 4, you get x is equal to 48. Now you can do this using cross products. You can go through and take 7 times x and 12 times 28, which for the sake of time, I'm not going to work it out, but it's 336. Then you would divide that by 7. And when you divide that, you get x is equal to 48, which is exactly the same answer that we used looking at that relationship between your numerators. For the second problem, 9 over 4 equals 5 over n. First, I look to see there is no easy relationship between 5 and 9. Then I look to see, are there any fractions I can simplify? There are not. So I need to solve this using cross products. 9 times n is 9n, and 4 times 5 is 20. So to solve this, I end up taking 20 divided by 9. I will show you this division as a quick review. 9 goes into 20 2 times. 2 times 9 is 18. I subtract and get 2. I bring my decimal straight up and drop a 0 down. 9 goes into 20 2 times. I get 18. Subtract and get 2. I can drop another 0, and I can see that this is going to be a pattern that keeps going on forever and ever. So my answer is 2.2 repeating. So I put a bar above that 2. And then on my third one, I check to see, first, is there a relationship between 12 and 8? No. Then I check to see, is there a fraction I can simplify? And yes, I can. I can divide both of these by 2, so I get 4/5. Now, all of a sudden, I have a relationship here. To get from 4 to 12, I multiply by 3. So since a proportion is just two equivalent ratios or fractions, they are equivalent fractions, so then I can just take the bottom by 3, multiplied by 3, and then I get n is equal to 15. Again, you would get the same thing if you used cross products, because you would take 12 times 10, which is 120, and 8 times n, which is 8n. So what you end up doing is dividing 120 divided by 8, which if you work that out, you will get the same answer of n equals 15. So to review, to solve proportions, check for a nice easy relationship between your numerators or your denominators. Check to see if you can simplify a fraction, and then you can always solve them using cross products. We use proportional thinking really quite frequently in the real world. A lot of times things have very consistent relationships. So, what's true for this amount, if we double it, we would double, 2 items and the relationship would stay consistent. So on a map, if an inch on a map represents 12 miles in real life, we might want to figure out how much, 3 inches represents. And, we do this by setting up proportions. So remember that when you set up proportions, your numbers that match or your numbers that go together either have to go vertically or horizontally. So all of these are solved, like I said, with proportional thinking. So we're going to set up a proportion. So if I set up my ratio, a ratio is just a fraction. So I'm going to say 1 inch is to 12 miles. And then remember, your information has to match up or down or across. So the other number that I have is 4.5 inches. Well, if I'm talking about inches on the top here, then I have to put that 4.5 inches over here. So then I can look, when I solve this unknown variable, I know what my label has to be. I'm solving to figure out how many miles they are. So I know right away that my label will be miles. Well, here it's just a proportion. I have 3 pieces of the 4. I can solve for the missing piece. So I'm just going to call this n. And I'm going to look for this relationship, because whenever you have 1, you can just multiply by this number. To get from 1 to 4.5, I would multiply by 4.5, which means since these are equivalent fractions or equivalent ratios, I would have to take 12 times 4.5. And that math looks like this. 12 times 4.5. 5 times 2 is 10. I carry the 1. 5 times 1 is 5, plus 1 is 6. Don't forget your 0 placeholder. 4 times 2 is 8. 4 times 1 is 4. Go ahead and add those up. 0, 14, 5. I have 1 digit after the decimal in the problem, so I have to move my decimal back 1 space, which gives me an answer of 54 miles. So what that means is, since this city measures 4.5 inches away from the ocean on a map, in real life, it's actually 54 miles from the ocean. When we solve percent problems, there are 2 main ways that we can do this. One is by using the percent proportion, which you will have to have memorized. And the percent proportion is when you set up 2 equivalent fractions. They are involving percents, so your percent is always out of 100. And then whatever number comes after the word of is always talking about your total, so that goes on the bottom. And then the clue word that you look for is, and that usually typically indicates your part. And that's kind of a little cheat proportion that you can use to set these up. So if you solve the first one using the cheat proportion or the percent proportion, 100 is always on the bottom. Your percent always goes on top. And if I look, that's what I'm trying to find, the percent. I don't know that. And in math, when we don't know something, we call it a variable. I'm going to call it P as a reminder that this is a percent. Then I look and see that what comes after the word of is the number 48. So I know that that's my total. So that needs to go on the bottom. And my part comes after the word is, and that's 42. So that has to go on the top. You could just solve this using cross products right away. You could take 42 times 100 and then divide it by 48. Or you can look at this and know that it's a fraction. Like I can look at 42 over 48 and say, you know what? I can divide both of these by 6. If I do 42 divided by 6, that leaves me with 7. And 48 divided by 6 leaves me with 8. And that gives me a smaller fraction and smaller numbers to multiply and divide. So now I'm going to look at 7 times 100, which is 700, and 8 times p is 8p. So my last step would be dividing 700 divided by 700 divided by 8. 8 goes into 70, 8 times. 8 times 8 is 64. When I subtract, I get 6. I drop down a 0. 8 goes into 60, 7 times. 7 times 8 is 56. I subtract. I'm running out of 0, so I'm going to add a decimal because that doesn't change my number. Bring my decimal straight up, drop this decimal down, and now 8 goes into 40 5 times, and there I'm done. This is my percent. So my answer, what percent of 48 is 42? It is 87.5%. Don't forget the percent sign. The second one I'm going to show you using the equation. The equation allows you to take words and change it into math symbols. And the one that you'll want to start with is the word is. Is in math is an equal sign. Following is, I have what number? That's something I don't know. In math, we use a variable. I'll call it n. Then over here, I know that of means multiply. So what I have on the other side is multiplying 2 numbers to find my variable. So I don't multiply by percent, but I can multiply by the decimal. So I'm going to change that to 0.8 times 22, and then that'll give me my answer. So I'm going to do 22 times 0.8. 8 times 2 is 16, carry the 1. 8 times 2 is 16, plus 1 is 17, carry that decimal over 1 spot. And so my answer is n is equal to 17.6. It is not a percent, so you do not put a percent sign on there. Remember that you can use either the proportion or the equation on every single one of these. When we solve percent of change problems, remember we're looking at how much something changes. So what we look for first is how much something changes, and to see how much it changes, you want to know, well, if I'm going from 8 to 5, how much does that change? The shortcut of doing that is just to remember that you subtract those numbers. 8 minus 5, it's a difference of 3. That's how much it changed. You always compare that to the beginning amount. So the before, it started at 8. From here, we want a percent of change. So change this fraction to a percent. You can either set that up as a proportion over 100, because percents are based out of 100, or you can change that to a decimal and then change it to a percent. If you do it this way, it would be 3 times 100, which is 300, is equal to, I'm going to call my percent P, is equal to 8P, divide both by 8. I'm going to come up here and work over to the side. 300 divided by 8, 8 goes into 30 3 times, that's 24, subtract and get 6. Bring down my 0. 8 goes into 67 times. I'm running out of zeros, so I need to add a decimal and another 0. Again, that doesn't change anything. Bring my decimal straight up. Now I can subtract and bring down this extra 0, and 8 goes into 45 times. So my percent, remember this is looking for percent of change, my percent of change is a 37.5%. And look, it's going down, so it's a 37.5% decrease. The other way that you can do that, if you don't want to set it up as a percent proportion or as, a percent out of 100, you can just go back and you can divide these two and get a decimal. If you take 3 divided by 8, you'll get a decimal. I'm going to do it real small down here. 3 divided by 8. Throw in a decimal, 8 goes into 33 times. You'll see my math is going to match what I did over there. 8 goes into 67 times. I'm going to show you. I can't fit the rest of it on, but it's 0.375. But this is a decimal. And to change a decimal to a percent, I move it over 2 places, and the same thing, I get 37.5%, and it is a decrease because these numbers are going down. All right, kiddos, I've been saying all along that you need to memorize 2 things. And the 2 things you need to memorize, the first is the percent proportion, and we have gone over it day after day, and many of you have it memorized. The percent proportion, your percent is always based out of 100, and then those words that you look for is over of, because is typically talking about your part, and of is talking about your total, and fractions are always written as part of the total. The other piece that I need you to remember is that when you do percent of change, you find the amount of change, or the difference, which you find by subtracting, and you put that over the original amount and change that to a percent. Good luck. I hope you all do well, and I hope that this video was helpful.